Hi, I'm Lisa Weiland with the Wabash Valley Astronomical Society. Last year, we held an in-person event, the Telescope Fair, to help people choose a quality telescope for a holiday gift. This year, with the pandemic, we're creating a series of videos to create an online version of the Telescope Fair. We hope this will help you choose the right telescope for your holiday gift giving. Our beginner telescope buying series consists of 6 videos. This overview with our recommended telescope, and then separate, more detailed videos about the 3 basic telescope types: refractors, reflectors, and catadioptrics. Plus, there are 2 more videos on mounts and accessories. So let's get started with our overview of things that you need to know to be an informed telescope buyer. What does the telescope do for you? The same thing the pupil of your eye does: collect light. Your pupil gets larger and smaller depending on how much light is trying to come into your eye. Under moonlight and starlight, your pupil expands to its largest size. If it could get much wider, like the front end of a telescope, you could see much more in the night sky. Telescopes collect that extra light and then compress it so that it fits through the pupil of your eye. The lens or mirror that points at the sky in a telescope is called the objective. The objective is a certain diameter or distance across. The word aperture refers to this distance. It determines the amount of light a telescope has to work with. The larger the aperture, the more light a scope can collect, and the more light it collects, the brighter and more saturated the image of the object you're looking at becomes. This allows you to magnify it more, thus giving you a more detailed view. Many objects in the night sky are very faint, so you need a wide enough aperture to collect enough light to get a good view of them. The bigger and wider the aperture, the more you can see. So let's look at some telescopes. First, we'll look at telescope types and mount types, and then we'll talk about telescopes good and bad. Every telescope has 2 equally important parts: the optical tube assembly, or OTA, and the thing it sits on, the mount. We'll look first at OTAs and scope types. There are 3 basic types of telescopes: refractors, reflectors, and catadioptrics. Refractors bend light, because refract means to bend. Reflectors use mirrors to collect their light, and catadioptric scopes use a combination of both a lens and mirror. There is no one single perfect telescope. All have trade-offs. Let's look at some refractors. Refractors use lenses to bend and focus light to create an image of your object. Make sure your lenses have quality anti-reflective coatings. The advantages of refractors: they provide sharp images with good contrast. They're great for solar system objects. The larger ones are good for astrophotography and deep sky. The disadvantages: all that perfectly ground, polished, coated, and fitted glass costs money for quality scopes. Small refractors leave you stuck at solar system objects without good resolution. You can get smaller aperture refractors for less money, but they sometimes come with bad mounts and accessories. If you want a small refractor, make sure it can be put on a different mount if the one in its package isn't good. Look closely at the accessories it comes with, too. More about those in a bit. Now we'll look at some reflector telescopes. Sir Isaac Newton designed a type of telescope that uses a curved mirror at the back of the optical tube to collect and focus light. These are known as Newtonian reflectors. The advantages of these reflectors are that you get great light gathering power for your dollar. These telescopes are versatile. They're useful for both solar system and deep sky observing. The disadvantages? They can be bulky and heavy, and their length can make them just a little difficult to transport. Now we'll look at some catadioptric telescopes. Catadioptrics use a spherical mirror at the back with a corrector lens and a secondary mirror on the front to collect their light. The advantages? Compactness of size. The design of these telescopes allows for a lot of magnification in a portable tube. The disadvantages? There's a little more to go wrong, of course, and cost. You have perfect grinding, figuring, and fitting of 2 mirrors and a lens, and coatings on the lens. Cha-ching, cha-ching, cha-ching. They're expensive, but they're nice. Now we'll look at mount types. A telescope's OTA by itself isn't much good without a way to aim it and hold it steady. For that, we need a mount. OTAs are typically connected to mounts with fork arms, with rings that go around the optical tube, or with trunnions that sit on the rocker box of a Dobsonian mount. There are 2 basic types of mount. Your altitude azimuth, more commonly called the alt-az, and equatorial. There are also tripods and motorized mounts. Alt-az mounts allow you to move your telescope up and down, and left and right in a full circle. So you can see any point in the sky. The advantages? Alt-az mounts are the simplest to use and set up, and they tend to be the lowest cost. The disadvantages? They need frequent nudging in 2 directions. Always west and either up or down, depending on if your object of interest is rising or setting. Now we'll look at an equatorial mount. Equatorial mounts allow you to move the telescope relative to the Earth's tilted axis and equator. The advantages? This mount allows you to move your telescope in only one direction to track an object in the sky. This is important when observing an object for a long period of time, like you do when you're doing astrophotography. The disadvantages? This type of mount is more complicated than an alt-az to both set up and use. They also cost more. Now we'll look at motorized mounts. As the Earth rotates, celestial objects appear to drift across the sky. To keep them in view through your telescope, you need to keep moving it. This can be done manually or with tracking motors. Motors cost more money. Go-to mounts use an internal computer to aim a motorized telescope at a desired celestial object automatically. You just type in the object you want, and the telescope slews to it. The advantages is that this is very fast and convenient, and it doesn't require knowledge of how to find objects. The disadvantages are that they're more expensive. They often take longer to set up. And again, they don't require knowledge of how to find objects. So you never learn the sky. Unfortunately, we don't have an example of our next mount, a push-to. These are relatively new. Push-to telescope mounts don't necessarily have motors, but they have electronics that tell you how to move the telescope to find the object you want. Advantages? They help find objects, and they cost a little less than go-to mounts. The disadvantages are there is some additional cost. Some mounts, like Dobsonians, can sit directly on the ground or on a table or a milk crate. But some mounts need to be elevated above the ground so that they're more convenient to use. Tripods can hold a mount and optical tube assembly at a comfortable height. Tripods need to be stable and not shaky. We've taken a brief look at telescope and mount types. Now we'll look at some accessories and then talk about what makes a good telescope versus a bad. Every telescope comes with a package of accessories: eyepieces, finders, and other things. Common telescope accessories include, as we just mentioned, eyepieces. These magnify the image your telescope has gathered for you. And focusers. These let you focus an object's image. And finders. Oops. These help you locate objects you want to look at and or the regions of sky that objects you want to see are located in. Quality eyepieces are 1.25 inches or 2 inches in diameter. 1.25 inch eyepieces can be put in adapters that allow them to be used in telescopes designed for 2-inch eyepieces. Quality eyepieces also have good anti-reflective coatings. Better eyepieces, your best eyepieces, are fully multi-coated. Quality eyepieces come in many different designs. Avoid ancient designs such as Huygens and Kellners. Reverse Kellners and orthoscopics are acceptable, but Plossls are a better overall inexpensive design. There are many, many other designs, but Plossls give good views of the sky and tend to be reasonably priced. Good focusers have adjustment knobs that turn smoothly and let you get as sharp an image as possible. Let's look at some common focuser designs. This telescope has a helical focuser. You just turn and turn and turn and turn this either way to try to bring your object into focus. These come with some lower-end telescopes. Cheap ones are sloppy and should be avoided. I personally don't like any of them. This is a linear rack and pinion. These come standard on low-end refractors and some reflectors. These are acceptable for most visual observing. This is a Crayford focuser. These come standard on most reflectors and mid-range refractors. These are good and allow both coarse adjustment and fine. Note that most consumer-grade catadioptric telescopes use a built-in focuser. Quality finders need to look at a wide enough region of sky to be useful. Ones that allow you to see 4 to 6 degrees of sky are good. When an object has been located as accurately as possible with the finder, it should also be visible through your eyepiece. There are many types of finders, including finder scopes. These are small wide field refractors, really, and dot finders. Quality finders should be adjustable so that the finder and the telescope will be pointing at the same thing. So let's look at what makes a good telescope versus a bad. When you buy a telescope, it usually comes as a package deal with a mount and some accessories. Look carefully at what you're getting. The eyepieces that come with it should be 1.25 inches across or 2 inches across. Do not buy telescopes that come with these tiny 0.965 eyepieces. These are less than 1 inch across. They also have no reflective coatings. Maybe they have 2 pieces of glass in there. It's just not a very good design either. Do not buy that kind of thing. And look at the mounts. Are they solid and stable? Or are they flimsy and shaky? Anytime you try to focus an image with this mount, anytime you touch this anywhere, you get vibration in the end. That means whatever your image is in the scope, it's going to start vibrating the minute you touch this telescope, even when you go to focus it. So you'll never be able to really focus an image that's shaking back and forth. Avoid this kind of thing. But the other possibility is, okay, this one comes in a bad mount, but can I remove it and put it on a better mount? If you can, maybe you can make a cheaper telescope kind of work. But not with those eyepieces. And that is the unfortunate fact. If it took 1.25 inches, maybe you could just replace the mount. It'd be good. Another consideration is what sort of finder comes with the telescope. There are many low-quality dot finders. Better ones have a little more width and lets you see the sky more. Finders ideally have thumb screws for adjustment. This one has thumb screws for adjustment. But many of the dot finders require you to use Allen wrenches to make adjustments, and that is much harder to do when you're aligning a scope. If there is an actual finder scope, 1, is it image correcting? If not, the view through it will be upside down and backwards to star maps, making using the finder scope difficult, to say the least. A finder scope should have a diameter that's larger than a drinking straw, and it should have some magnification to it. Do you need a right angle finder to use it comfortably with your telescope? Many scopes often come with a straight through finder, like this one. It doesn't have an angle, you just look straight through. Well, now picture yourself pointing the scope 90 degrees up or near. Can you still use the finder scope without laying on the ground? If I were using this one, I'm way down here to try to look through it. But with the right angle, I can just Bend comfortably down a little bit. Same thing when the scope is lower. Are you bending way over to see through it? Or can you just bend down a little bit? Much more convenient when you have this sort of telescope to have a nice right angle finder. Some refractors and catadioptrics are designed such that you're at the back of the telescope and not at the front. In that case, a straight through finder tends to be better to use. So it depends on your telescope what you need. But don't forget your finder scope needs to be alignable. Any finder needs to be alignable. Avoid buying a telescope with a tiny drinking straw-sized finder that's in a fixed position. This finder is essentially useless. The telescope's pointing at one thing, the finder's most likely pointing at something else, and there's no way to change that. You can't adjust them to be pointing at the same thing. See our accessories video for more details on eyepieces, finders, and other useful accessories. Now we're going to talk about what makes a good refractor versus a bad. First of all, just the way they're advertised is a big clue. Good refractors are advertised for the quality of their optics and the materials used and the coatings used. Bad refractors come in a box with Hubble Space Telescope pictures of objects all over it that go on and on about their power, what power we have, 600 times and stuff like that. Totally ridiculous, especially for the tiny amount of light that you're gathering from them. Good refractors have good quality anti-reflective coatings. Good refractors are more than 2.5 inches or 60 millimeters in diameter. They're at least that. Good refractors can be placed on more than one mount. As we've shown, sometimes you need to replace the mount it comes with. Bad refractors tend to have apertures smaller than 2.5 inches. They also have poor or no reflective coatings on the lenses and poor focusing mechanisms. Sometimes they come locked onto one included mount that's of poor quality. Now we'll talk about good and bad reflectors. In reflectors, good optical tube assemblies have a Newtonian design with mirrors that are parabolic, sometimes called paraboloidal, in shape, and they're at least 4.5 inches in diameter or larger. These telescopes usually already come on a nice solid Dobsonian mount. Some come with other Altaz or equatorial mounts. I don't have one here, but bad reflectors often have spherical, sometimes called spheroidal, mirrors, and they're smaller than 4.5 inches in diameter. There's also a Bird-Jones design that is more difficult to deal with in terms of maintaining the telescope alignment. Fortunately, it's rare to find this design. See our reflectors video for more information. Finally, we'll talk good and bad catadioptric scopes. These telescopes tend to be well made. There are different designs. The popular Schmidt-Cassegrain and the Maxitov, these are the most popular for visual observing. Ritchie Crichtons are popular for astrophotography. But I've not heard of any poor catadioptric telescopes. So to recap, our bottom line on refractors are good refractors talk about their excellence of optics just in the way they're advertised. They have glass lenses. They have an aperture of 2.5 inches or larger. They have coated or fully multi-coated lenses. They have a mount that is able to be changed or already solid, an alignable quality finder, a nice quality Crayford or smooth rack and pinion focuser, and a quality eyepiece and mount package.
Bad refractors? Some have plastic lenses. Oh my, just avoid those. They have an aperture that's smaller than 2.5 inches, poor or no anti-reflective coatings, a mount that is shaky and can't be changed, a fixed, tiny finder, a stiff, notchy rack and pinion focuser, or a poor eyepiece and mount package.
Take note of the differences when you choose which refractor to buy.
Our bottom line on reflectors are that good reflectors have a Newtonian design, a parabolic mirror, an aperture of 4.5 inches or larger, a nice stable solid mount, a quality alignable finder, a nice smooth Crayford or quality rack and pinion focuser, and a quality eyepiece and mount package. Bad reflectors may have a Bird-Jones design or a spherical mirror, an aperture smaller than 4.5 inches. They might have some sort of shaky mount, a fixed tiny finder, a cheap helical focuser, or some stiff notchy rack and pinion focuser, and just avoid any poor eyepiece and mount package. We want to be sure your expectations are realistic so you won't be disappointed. Pictures of space objects that you see on TV or the internet are long exposure photographs made with expensive, advanced telescopic equipment and cameras. Your eyes can't offer the same views because of the way your brain processes images coming from your eyes. With that in mind, here are a few examples of realistic eyepiece views taken through 10 or 12-inch telescopes compared to time exposure astrophotos taken by our members. Objects in space are extremely distant, and many are very faint. Just knowing that the light from these objects has traveled through space for thousands or millions of years to finally end up hitting your retina so you can see it is pretty amazing. This is the benefit of observational astronomy.
The telescope you need depends on what you want to do with it. Kids and hobby beginners tend to prefer looking at solar system objects like the moon and the planets. There is more to see. There are deep sky objects like nebulae and star clusters and galaxies. These deep sky objects tend to be of more interest to older children and adults, and anyone with experience in the hobby. For most beginners, we recommend a Newtonian reflector on a Dobsonian mount. These telescopes are versatile, they're simple to set up and use, and they have the lowest cost per inch of aperture. Hopefully, this has been a sufficient introduction for you to see what kinds of telescopes there are that you might consider. For more information, see our individual telescope, mounts, and accessories videos. For more information on pricing and other recommendations, see our recommended telescopes document available on our website at wvastro.org, or you can always contact us by email at wvasinfo@gmail.com. Happy holidays and clear skies.